My husband and I were really excited to cook together when we moved into our first home a few years ago. And so we decided to skip dinner and go straight for dessert, making my favorite peanut butter cookies to christen our kitchen. Well, a half an hour later, there were black particles flying all over the kitchen, the oven was on fire, and about a dozen police and firefighters showed up. I was mortified to find out that the cause was a oven mitt that I put in the broiler, thinking it was a drawer when I was unpacking. Now, smoke in our homes isn't normal, but for this woman who I met a month ago in Ghana, it's a way of life. She cooks 3 meals a day over an open fire. Her stove are 3 stones with a pot on top and firewood underneath. And women all over the world spend their entire lives over these fires, and they're often even inside their homes. And so 10 minutes of cooking over this kind of traditional cook stove is equivalent to smoking 400 cigarettes. The smoke contains a lot of gases and particles that are really toxic, and they contribute to respiratory and cardiovascular illnesses. Over 4 million people die every year from this type of cooking. Many are children. That's more people than from malaria and HIV/AIDS combined. Imagine learning that cooking for your family was killing them. Now, cook stoves don't just contribute to, your health, but they also contribute to climate change. For example, the pollution from these cook stoves enters the atmosphere, it interacts with sunlight and heat, and it basically impacts our very delicate energy balance. So emissions from cook stoves contribute to the 3 major warming pollutants that contribute to climate change, which are carbon dioxide, methane, and black carbon. So these 3 pollutants contribute to 84% of the warming that we're experiencing today, although only a few percent of carbon dioxide and methane are actually coming from cook stoves. Most are coming from other sources like fossil fuel combustion, deforestation, agriculture, natural gas. For black carbon, however, around a quarter of the emissions are actually coming from cook stoves. And so these cook stoves are adding a decent amount of dark particles into the atmosphere that are trapping extra energy from human activities. And so these black carbon particles contribute to changing the energy balance in 4 different ways. The first is they're very powerful at absorbing sunlight. They can trap 1 million times more energy than CO2 pound for pound. They also can burn away clouds because they absorb so much energy. They provide local heating in the atmosphere, and so they evaporate clouds, less sunlight. More sunlight can come and hit the earth. The third impact is that they are deposited in snow and ice. We saw that in an earlier presentation. So they absorb a lot of sunlight, they melt away snow and ice, and then they end up causing even more warming. And the fourth impact is actually cooling impact. They can trigger cloud growth because they act as a surface for which the water vapor to condense on. And so they can end up creating more clouds or clouds that last longer or brighter clouds, and so this has a cooling effect on the planet. And so black carbon is never emitted in isolation. It is also emitted with its counterpart, organic carbon, which is a cooling aerosol, and it reflects sunlight as opposed to absorbing it. The balance between these two determines the overall effect on the climate. And so this balance is very sensitive to a lot of things, such as the type of fuel you use, the burning properties, the combustion, the fuel cycle. Over here on the left, this would create more black carbon relative to organic carbon, and the opposite on the right. The right is more smoldering, the left was more of a burning fire. It gets even more complicated because black carbon particles can absorb some water, they can absorb other they can absorb other liquid aerosols, and they can mix with other solid aerosols, and so they change their shape and their size, and it gets to be really complicated. They can affect the energy, the way that they're affecting the energy changes all the time. And so scientists, it's just like this huge challenge in terms of how do these cook stoves that emit so much black carbon actually impact the climate. And so the overall way that I like to look at this is that we are going to be replacing cook stoves anyway because they are such a health crisis. And so my role as a climate scientist is to determine when we switch from one method to another, how is that actually going to impact the climate? So not how are they impacting the climate now, but how are these different technologies changing what the climate looks like? And so just like we don't want cooking to kill our families, we don't want it to kill our planet either. Thank you very much.